Hello student, myself Nimesh Prabhakar. Welcome to Process Control lecture series. In my previous lecture, I start new chapter. That means in that lecture we discuss about the controller tuning. So in that lecture we discuss what is controller and why we require tuning of controller. Then after we discuss about the simple performance criteria. Then we discuss about the time integral performance criteria. And now in this lecture we discuss about the tuning method. So in this lecture we discuss about the controller tuning, and in that we discuss two tuning method. First one is process reaction curve method. And second one is ZN tuning method. That means Ziegler-Nichols tuning method. ZN, that means Ziegler-Nichols. So in this lecture we discuss about these two tuning method. So now we start the lecture. So we discuss the controller tuning first. When the type of feedback controller has been selected, that means we select which type of controller we have to use. That means we select we have to use proportional controller, or we have to use the integral, or maybe we have to use the combinational controller like the PI controller or PD controller. We choose that controller. Now we still have the problem of deciding what a value to use for its adjustment parameter. That means which value here we talk about the value of KD, KP and KI. That means the gain of controller. Which value we use to give the gain. So the value is very much important. So first we choose the first we choose the controller. So here we choose controller. That part is our own closed. Now here the second one problem come in our mind or come occur is to choose the value of KP, KD and KI. So this is known as controller tuning problem. There are three general approaches we can use for tuning a controller. So which are that? We already discussed two of them. So first one is use simple criteria such as the 1/4 decay ratio, then after minimum settle time, then after minimum largest error and so on. So these are the simple criteria. That means we discussed about the simple performance criteria. In that we discussed the rise time and settling time. So adjusting the rise time and settling time, we can tune the controller. So this is the simple method to tune the controller. This approach is simple and easy to implement. Now second one method of tuning is use the integral performance criteria. So which are the integral performance criteria? We already discussed it in the last lecture. So the integral criteria are ISE, IAE and ITAE. This approach is rather cumbersome and relies heavily on the mathematical model of the process. So this is the second one method of tuning the controller. And now last one method, so which is that use the semi-empirical rules which have been proven in the practice. So by using the semi-empirical rules, we can tune the controller. So these are the three methods used to tune the controller. Now we discuss about the general method of the controller tuning that developed by the scientists. So which are that? So as per syllabus, we discussed about the two methods of the tuning of the controller. So first one method is the process reaction curve method, and second one method is ZN tuning, that means Ziegler-Nicholas tuning method. So we discussed about these two methods of controller tuning. So first we discussed about the process reaction curve method. This is the simple diagram of this method. You can see this is the closed loop system and we divided from the upper part. So this method is developed by Cohen and Kuhn. These two scientists developed this method. This is basically an open loop technique of tuning. There are the two techniques. First one is the open loop, and then after we discuss in a Ziegler-Nicholas, that technique is known as the closed loop techniques. So this is the open loop techniques of the tuning of the controller. Here the process is assumed to be stable first order system with time delay. So here first one consider or the assumption is taken is that the process is stable and first order system with time delay. Now the closed loop system is broken as shown in figure. So here the upper portion of between the G1 and G2 is we have broken. So between the controller and accumulator we have break the process. That means between M and M'. Now we give input to the M' and measure output at B. That means after the feedback system, the reverse B, we measure the output. In fact, a bias input may be necessary so that the plant output initially become close to the nominal value. So that means by using these techniques, we require the bias inputs so that the plant output initially become close to the nominal value. The step input is supervised on this basis of bias value. The input and the output response are plotted by the suitable means as shown in figure. That means we give the input at M' and measure output at B. Then we plot the value of the output accordingly input in the graph. So now we measure the value of M, N and K from this graph. That means if we plot the graph, then the graph is like this, and from the graph we measure the value of M, N and K. Let us define the following terms corresponding to figure. So now we define this term, that means here in this figure N is indicate the slope of the curve, then the time constant T is defined by the K by N. So we have the value of the K and the N from the graph. So we can get the time constant by using this equation T is equals to K by N. And then after the last one, we define the leg ratio R by R is equals to L by T. So here we have the value of the L and T, that is time constant. So we can find the leg ratio. So we define this term, that is slope, time constant and leg ratio by plotting the graph. Now then the recommended optimum setting for the PI and PID controller are followed. That means we can find the optimum value of Kp and for the proportional controller, PI controller and PID controller by using this. That means for the proportional controller, Kp value we can find by using this equation. That means Kp is equals to N by NL into 1 plus r by 3. So we get the value of Kp. So for the proportional controller, we get the value of Kp. So here we achieve our aim. That means we get the value of gain Kp. Then for the Pi controller, we require the value of the Kp and Ti. Ti is nothing but the Ki, we can say in the other words. So for the Kp, we can find the value of the Pi controller. For the Kp, we can find M upon NL into 9 by 10 plus R by 12. And we can also find the value of the Ki or Ti by using L into 30 plus 3R upon 9 plus 20. So we get the value of the Kp and Ti for the Pi controller by using this second one equation. And for the PID controller, we require the value of Kp, Ki and Kd. So for the Kp value, we can find out by using this equation, that is M upon Nln 4 by 3 plus R by 4. For the value of the Ki or the Ti, we can find by using L upon 32 plus 6R upon 13 plus 8R. And for the value of the D, that is the derivative controller, the value of the Kd, we can find out by using the Td is equals to L into 4 by 11 plus 2. So here we finally get the value of the Kp, Kd and Ki, or we can say in the other word Kp, Ti and Td for the different proportional, for different controller. That means for the P controller, for Pi controller or PID controller, we can get by using this equation. So this is the first one method of finding the value of Kp, Kd or Kd, or we can say the tuning of the controller. Now we discuss about the second one method. So the name of this method is the Janet tuning techniques. That means Ziegler-Nicolai tuning method. Unlike the process reaction curve method, which used the data from the open loop response of a system, the Ziegler-Nicolai tuning technique is a closed loop procedure. That means here we discuss about the closed loop procedure. In the process reaction curve, we had discussed about the open loop. That means we divided the portion of the upper part. So that's why it is called the open loop system. And here we discuss about the closed loop system. It goes through the following steps. So these are the steps for the Janet tuning method. So first one step is bring the system to the desired operation level. Then second one step is using proportional controller only and with the feedback loop closed, introduce a set point change and vary proportional gain until the system oscillates continuously. Now understand the second one step. So here we use only proportional controller and closed loop system, and now we change and vary the proportional gain until the system oscillates continuously. So this is the second one step. Now third one step. The frequency of continuous oscillation is the crossover frequency omega C0, and let M be the amplitude ratio of the system response at the crossover frequency. So we note these two terms, that means crossover frequency omega C0 and then the M, that means the amplitude ratio of the system response at crossover frequency. Now step number 4. Compute the following two quantities. First one is ultimate gain Ku. We can compute by using equation this Ku is equals to 1 by M. We already know what is M, and then ultimate period of sustained cycling. So this is the Pu, and we can get by using this equation 2 pi upon omega c. So now for one step is to compute the value of the Ku and Pu. Now the procedure is complete. How? Now we have the value of the Ku and Pu, then we can get the value of the Kp, Kd and Ki. How? By using this table. So same we discussed in the reaction curve method, same as for the only proportional controller, we can find the value of the Kp by using this equation, that means K by 2. So we get the value of the proportional gain Kp. Now for the value of the for the Pi controller, the value of the Kp and Pi we can find by using this equation, that means Ku upon 2.2. So we get the value of the Kp, and for the value of the Ti, the Pu upon 1.2. And for the PID, we get by using this equation, that is Ku upon 1.7, so we get the value of Kp. Then for the Ti, we get the Pu upon 2, and for the Td, we have the Pu upon 80. So we get the value of the Kp, Ti, Td for the different controller, that means different mode, that is a P controller mode, Pi mode or PID mode we can get. So this is the second. So we can get the value of the Kp, Ti and Td for the different controller mode, that means P mode, Pi mode and PID mode by using this table, and the value of the Ku and Pu. So these are the steps to get the value of the Kp, Kd and Ki. So this is the second one method of tuning, and the name of this method is Zn tuning, that means Ziegler-Nichols tuning method. So now we complete this method. Now we discuss about the advantages of these techniques. So first one is does not require, that means Zn tuning techniques does not need or require the expert knowledge. Second one advantage is does not require model of system. That means we do not require any mathematical model of the system to tune the parameter. And third one advantage is often produce good initial Kp, Kd and Ki. Now we discuss about the few disadvantages of this tuning technique. So first one is not mathematically rigorous. So this is the main disadvantage of this technique. Now second one is it requires stable system. So this is the first one limitation of our to use the Zn tuning, because we can apply only when the system is stable. Otherwise we cannot apply this tuning method. Now next one is if you do not have model, real experiment could be costly. That means if we use this technique without modeling, that means we already discussed the advantage is that without the technique, without the model we can use this technique. But if we apply any tuning technique without model, then cost is increased. And the last one is require a system that can be driven in unstable with increasing a proportional gain. Sorry, this is the proportional gain. So this is also a limitation. That means we have to require the one system that can be driven unstable with the increasing the proportional gain. Then after we can perform the step number 3 and step number 4. So these are the disadvantages of this Zn tuning. So here we discuss about the advantages and disadvantages of Zn tuning techniques. So in this lecture we discuss about the controlling tuning method, two methods. First one is the process reaction curve method and Zn tuning. So as per the GPU point of GPU, this two method is very important, because many times asked in a GPU paper explain the process reaction curve and and Ziegler-Nicholas tuning method. So this two method is very much important, and